do this. Calgary, I hope you've got the link up and working. Could I just get a thumbs up again to let me know, please? Maybe Dave's there. Yeah, thanks, Dave. Thanks, Dave. Can always count on you. All right, we got to talk about more SQL stuff today, and we're gonna do some more advanced queries than what we were dealing with this morning. You notice I didn't do a lot of queries because I got kind of behind in time. I should have some more time today to do some more complicated stuff. I want to show you how to sort of compose queries from sort of simple up to a bit more complex, because it's never the case for me, at least, that I think, oh, here's the query that I need to do, and I just sit down and write it. I tend to build it up step by step because I can think about it a little bit easier that way. Before we get into that, though, I just want to ask, does anyone here think that they could potentially write code faster than what the SQL query could produce for us? So we do a SQL query, gives us back some results, or we write some code that does all the filtering and all the where and all that kind of stuff, and it's JavaScript. Who do you think's faster? What code do you think would be faster? Yeah, the database is going to be faster at this because JavaScript, for a number of reasons, JavaScript's a dynamic language. It's pretty fast, but definitely not written. It's not C++ fast, right? The database, though, these databases implemented in a fast language like C++. Also, SQL is designed to have your database take the query and then try and figure out what the fastest way to get that data is. And this is over a long time that people have been working on this. So lots of improvements there. I guess my point is that if I wanted to do a query from our database that retrieved all of the students and their cohort name, I could retrieve an array of students and an array of cohorts. And then I could go through that array of students, and for each student, this is now I'm talking some JavaScript, right? For each student, I go and grab the data from the cohort, and then I create a new object out of it, and now I have my essentially joined table. So this code could do that for us. At the top here, I'm going to just zoom out a little bit, I think. Yeah. This way I can use the pointer to show you. So here, I've kind of labeled it with the things that would be very similar in SQL. So I'm going to map over the entire students table. That's kind of me saying from students. I'm identifying it's the students table that I want to go through each of the records in the students table. And then for that, I want to join the cohorts. And the condition that I'm using is that the cohort ID matches the student ID. And actually, that's very similar here, is if I'm looking at one specific student, I can grab from the cohorts, I can find the cohort that student belongs to with pretty much the same condition, right? And so this would give me back information about that cohort. And then I could go down here and essentially join the columns together or put the columns together. It gives me the ID, the student name, and cohort name. Right? So does this kind of look like what we did with our join, right? So how long do we think it would take to execute code like this? Don't forget that if I execute it on this machine, as long as I do all of my measuring on this machine, I can compare those things. But I cannot compare something I measure on this machine to something that you measure on your machine. Those are two different machines, and so we can't compare the times. So I'm looking for like a rough idea of how long we think this might take. Great point. It depends on how big the data structure is. So I'm going to just tell you right now, it takes 27 milliseconds maybe to run this code on this computer. And on the same computer, if I were to do the SQL query instead, it was 7 milliseconds. So that's actually a pretty big difference, but probably not big enough of a difference for us to care right now. Like the 20 milliseconds is, we're not going to notice that. OK, but we were dealing with like 190 students and 12 cohorts or something like that. So that cohort list that it has to go through and search linearly through every time is a pretty short list. So it's not going to take that much time. But what happens if we actually change our query? And what we want to do is figure out how many, all the students and the number of assignments they've completed instead. Okay. So we could write the JavaScript to do that. All we need is an array of students and an array of assignment submissions. And we can go through every student and then filter out the assignment submissions for that student, gives us the number of assignments that that student has submitted. We now know the count for that student. And we do that for every single student. So we end up with an array of objects that contain the student name and the number of assignments they've completed. So how long do we think this might take? The last one, remember, 27 milliseconds. 72,000, I think, in the assignment submissions. Just a lot more is a good answer. In this case, what I measured, it was just over a second to do this. That's way too much time. Because if I write the query that does that, sure, it feels a little bit more complex because we're pretty familiar with JavaScript. I think most people could write this JavaScript. And we're trying to learn how to write that SQL query. Feels a little bit complicated. 42 milliseconds to execute that same code. So the database is doing all the work as fast as it possibly can for you. This is a good thing. This is what we want to get to. So my point is, we're very rarely going to ever beat the database in terms of speed. So let's put as much responsibility on the database as possible and let the database do as much as it can with SQL queries. Okay? If I index the count by the student ID, so what I actually end up doing is I've got these examples that you're seeing on the slides are all, I have the code here as well. It's not just on the slide. So this, I want to find the complex example here. So all this file is, and if I run it, it actually tells us how long these things take. Node, we'll do complex example.js. It's saying the basic query takes 558 milliseconds, and then the SQL query takes 27 milliseconds. That's on this machine. I measured it on a different machine. That's why you're seeing the difference. OK. So what this code does is it does that query, gets the information, and then passes off to the JavaScript to actually do the filtering and the returning of the actual result. Here. Now, every time it has to go through and filter. For every student, we have to go through the entire assignment submission list to filter out the assignments for that student. That's where a lot of the time for this is coming from. We could index this instead, and what that would mean is basically going through. So, yeah, what we would do is we'd actually create a table, an object, where every key in the object was a student's ID, and then that ID would have the number of assignments they've completed. And so we could create that list once. So it would go through the 72,000 results once, or the 72,000 rows once, instead of once per every student. That's a really big savings. So indexing is a solution to this problem. Although we still go maybe from a second down to 712 milliseconds, still not fast enough, even with indexing. So let's use SQL for that. OK. So my point is, don't fall into the trap of writing the stuff in JavaScript that we should write in SQL. Is that OK message? OK, good. So here's some scenarios. Now we're going to get, hopefully, into some more interesting database queries. So these scenarios are things that I thought of about when I was thinking about the data that we have. It's all about students and cohorts and a boot camp scenario. So there are different people that could come up with requirements, right? You've got the people working on Web Compass. Maybe you have the education staff wanting to find out things about the current cohort and how someone is doing or how everyone's doing in relation to each other. So you might have situations where someone in the business says, I want to find all inactive cohorts, identify how many assistance requests were made per student on average. That's something we could query for. We could actually take our data set, write a query, and get back the answer to this question. I want to know all the students that are currently active. I want to display the number of complete and the total assignments that they should have completed by that point, right? So this might be a way for us to figure out if people are falling behind or whatnot. Other scenario, find all the teachers who are currently active and display the number of assistance requests they completed since the beginning of December. I mean, these are pretty arbitrary questions, but they kind of, you can ask these questions and our database has the data in it. If it has that data, we can actually do queries to get the answers to these things. Find all active students that have a rating of less than 2. So maybe if someone's struggling, we'll be able to identify that. Find all active students and display their requests per day and average rating. This one's kind of useful. If I found maybe that a student had a lower rating, I could check to see how many assistance requests that they were making. And if they were not making a lot of assistance requests, then I would identify that as being something we have to address, maybe have a conversation with that person. Why are you not asking for help? The help you are asking for is telling us that maybe you're struggling a little bit. let's get that assistance request number up a little bit. And we can actually measure it now and measure it in 2 weeks from now and figure out if that's made a difference or not, right? Find out how many assistance requests have been created for each assignment. I find this could be interesting because this might tell us the quality of our assignments. If assistance requests are made, you know, an order of magnitude more for one assignment, then that assignment needs to be fixed. There's no doubt about it. Find out which assignments a specific student hasn't finished. So that could be pretty useful, I think, for a few different reasons. One, from the administrative side, right? So if we want to maybe get a list of all the students in the current cohort, figure out which ones are behind on their assignments. Or maybe you just go into Compass and you're given a list of all the assignments you haven't completed yet. That's another useful reason to make this request, or do this query. So I can do 2 or 3 of these at least. Did one pop out as interesting to someone? Because otherwise I will just choose one and we won't get through all 7, I promise that. Worst assignment. Okay, yeah, so this one here. How many assistance requests have been created for each assignment? So we could figure out, yeah, where the anomalies are and try and address those specifically. Cool. It is not real data. It is simulated data that tries to represent real data. Sorry. It's not fair. Your privacy is important to me. Yeah. But just so you know, this data, I wrote like a sim. So I wrote something that would go through every day, and on every day it would identify which students were currently active, and then it would figure out sort of every student kind of had, it's all fake names, but every student that was generated, they were sort of randomly given a capability number. So they ask for more help, and they do a little bit worse on the assistance requests if their capability is a little lower. So we do, but it's pretty random. So this data set does have some people that are outliers. It has some people, but for the most part, it's just kind of like simulated over time. And I wanted to create a data set that not only I could use for the lecture, but I also thought it would be really important that if you wanted to play with SQL queries, SQL Zoo is okay. I think that the interface is garbage. But I don't think it's very useful to do queries on very small data sets. It doesn't allow us to really learn much about SQL. So I've made this available to you. What you do is you go into the notes for this. Let's go here. And in the repositories, we'll go down to SQL notes. So from this morning. Oh, that's not it. That's a different one. SQL intro. There it is. You can go into Bootcamp here, and the schema is the same schema I'm using. I just imported this file, just like you have done, I believe. I think you did this with your SQL file. Once the schema is set up, here's the seed. The seed, it doesn't show it here because it's 17 megabytes, but it's hundreds of thousands of rows of data. Okay. And I can actually just go in and take a look at it. Week 4, day 1. Select count ID from, let's say, assignment submissions. Oops. 72,000 assignment submissions in this. They're all fake, but at least it gives us a pretty good set. Okay, I'm going to open up this tool here, Postico. Sorry? It's called Postico. Postico. Yeah, it's like a GUI tool for working with Postgres databases. The reason why I want to do this is because I find I'm going to bring the font size up here. I think that's right there, and the font size for the result, I think 18 is pretty good last time. Okay. Is that okay? Should I bring that up a bit? Maybe a little bit more. That's better, I think, right? Okay, so I'm going to write the query up here. What I like about this is it's actually really easy for me to write multi-line queries, and I think that although queries don't need to be multi-line, for legibility it's a bit better. And then we're also going to see the results down here. And it's a little bit easier than when I do this, when I make these queries, and then because I've got it zoomed in, it line breaks, and then you get one row across multiple lines. I didn't want to deal with that. It's not a problem for me. I like to use this myself normally because my font size goes down, and then it can fit all on the same screen, and it's not a big deal. But right now, when I'm doing the demo, I don't get both. But at least this way, I can scroll back and forth, and every row should be on its own line. Okay. So what the process I'm going to use for this is I'm going to go over to my notes, and I think it's really important for me to run the query first and show you what the results look like, and then we build up the query from scratch, rather than just saying, let's just start writing the query, and you don't really know what we should get back as a response. So all the examples are here. Answer, they're already here. I'm going to go find the number 6 here. All right. So here's the query, and I'm going to run this. So remember, we want to get back a list of all the assistance requests for every assignment. It's the number of assistance requests per assignment that we have in our database. And I think there's about 424 assignments. So we should get about 424 results back. I execute the statement here, and this is the data that I get back. I get the name. They're randomly generated, so they shouldn't make any sense. I get the duration. That was just something I included in the column selection here. But then here's the count. So this first assignment, 17 assistance requests on that first assignment. All right. What about if I order it? Okay, these two assignments here, 424 and 423, they have many, many, many more assignments we can see, or assistance requests. So we were able to figure this out from this query here. Ready to build it up. Okay. I always just start with a select query, and I just start with star. I don't need to filter out columns yet. I just kind of always just put star there. And then what I'm trying to do is find all of the assignments, the number of assistance requests that that have been generated per assignment. So I know that I'm going to need to join the assistance requests, and maybe I need to actually join the assignments onto it if I want to get its name, for example. But I think that I could get, I could start by selecting the assistance requests. 6 star from assistance requests, okay? So I'm just going to run the query now and see what I get back. Okay. So here it is. 26,000 rows. So that means that there have been 26,000 assistance requests. We can see that there's a student ID, so we know which student made the request. We can also see that there's an assignment ID. Okay. So I now need to join the assignments to these assistance requests. And I need to join it on something. So what's the condition I could use for this? Okay, so I've got a foreign key, right? And that means the assistance request table has a assignment ID, and the assignments table has an ID. So I'm going to say that the assistance requests dot assignment ID is equal to the assignments dot ID. Okay. Now it's going to, for every assistance request, it's also going to give me information about the assignment for that. And I run it, and all that data on the left side is still the same, but now I'm getting information about the assignment with each one. Okay. So now what I need to do is count the number of unique assignments, or I probably shouldn't use the term unique, it might mislead you, but because that's actually something in SQL. But what I want to do here is I want to count the number of requests for each assignment, and so that means I need to group. I need to group these things. I need to create groups out of this result set that I have right now, and each group should represent all of the requests for one assignment, right? Does that make sense to people? Okay, so I should group now, and I'm going to group by, let's say, assignments.id. And I could group by assignments.id, and I could group by assistance requests assignment ID. Both of those things are going to be the same here. We're going to see 6 is the same over here as 6, 9 is 9. So I could do either one. I just find the way that this is written here, where I'm actually grouping by the assignment ID, it's a little bit more clear what that means. It's also less right typing, so I kind of like that. You could group by name. Now, I don't think any assignments would have the same name. Ah, well, I could, but what if 2 assignments had the same name? They shouldn't, right?
Yeah.
But I know for sure that no IDs will be the same, and so that's why I would choose to use ID by default. Is that when I group, I want to make sure that these values are grouped properly. So in case I wouldn't, like a person's name, it's very possible two people have the same name. So grouping by that could give me the wrong result. So I default to using IDs as much as I can for these things. Yeah. Okay, so when I do this group, we're going to notice that it actually gives me an error. It's saying column assistance request ID must appear in the group by clause or be used in an aggregate function. So we're going to get this a lot if we just use a group by, because what happens is it doesn't really know what to do with these groups, and it doesn't know how to show that these are groups. So we need to convert those groups into, for each group, we get a row. And that row is going to be the information about the assignment and how many assistance requests were there. So I would say that what we want to do, is count the, I guess we could just count the assignments. Let's try this first. So I get 424 rows back. Is that a good thing? How many assignments were there? Do you remember? There were 22,000 assistance requests, but there were 424 assignments. And I expect that we'll get 424 results back because I want to know for every assignment how many assistance requests there were. So I think that 424 is a good number because it matches the number of assignments that I have. And of course, it's easy for me just to select star from assignments again, and I can find out how many assignments there are this way. Down here, 424. So I think that that previous query that I did, this one right here, that looks right to me. I'm only seeing the count here, but now's the time when I fill this up with a little bit more relevant information. It looks like I have the count, so for every assignment, the number of assistance requests that were made. So now I just want to add in maybe the assignments.name, and we'll see what the name is for each of these. Okay, and maybe also actually just the assignment ID. We could show that as well. Just come out. There we go. Okay, the ID is second there. I kind of like to have that first, so I probably put that up here. I run that again, and I'm just running it every time. Here's the ID. I'm not ordering it by anything. I can always click on this to kind of get that, but I could also, if I'm in something else, order by ID. I'd probably have to say assignments.id. Okay, now it's actually ordering from the lowest ID to the highest ID. So this query seems to do that for us. Any questions about this? Yeah.
Could you perhaps elaborate on how this query started working when you added the count assignments.id? Because that seemed to be what allowed the error.
Yeah, so if I left it like this, right?
Right.
The error is saying that I've done a group, but because I've got, if I leave it like this, the query is just sitting there and it's grouped all these results up into these different like buckets almost.
Right.
It doesn't know how to take each bucket and convert it into a row. So what I need to do is say for each of these groups, just count how many rows you have. And so when I say take each group and do this, run this aggregate function over each group, which means count the number of. Yeah, that work.
Could you do star comma count? Is that also okay?
I don't think you can do that. I think once you choose, no, it doesn't like that. Because again, it doesn't really know what to show there. So I just do the count, and then I get back just the count value. And I can say as assignment count or AR count or something like that, and I can rename that thing. So now this column is called AR count. But yeah, the main thing is that once I've done a grouping, it's put all the results into the different buckets. Now I need to be able to take those buckets and convert them back into sort of something that can represent that group as one row rather than 6 rows or 12 rows or 17 rows. Yeah, okay. No problem. Okay. Anybody have another one they'd want to try out? What's the next one? So we've got, let's see. That one's all right. Find out which assignments a student hasn't finished. This one's kind of fun. Okay. Okay, move on for this one. Okay. Again, all of these are in the notes. Play around with them, load the data in, play with them, try it out, because that's the only way I learn this stuff. Let's run this and see what we get. I'm getting back. So what I had to do here is I actually had to identify one student. The student is number 159. So every student has an ID. I know what the ID is. So with that ID, I should be able to find all the assignments that student has not completed. I'm doing, yeah, I guess, so this is actually just giving me back the assignment ID and the name. Okay. So it looks like they finished 257 of the assignments out of 424. But that's okay. I mean, I don't know at what point. Let's see where this student's from. So select star from students where ID equals 159. Who is this person? It's Shannon Tromp. And Shannon's ID is 159. Shannon started the program 11/19. So remember I told you that this data goes until January 1st. So Shannon's still in the, currently in doing the program. And that's okay. So not having all the assignments completed, that's okay, right? No one expects you to have all the assignments completed if you're still in the program. So we're just trying to figure out for this student how it is. So that's okay. I think that's an all right thing. It seemed like a lot. I heard some reactions, but maybe now it's not that big of a deal because they've only been doing this for like a 5 weeks or something, 6 weeks. Yeah. Probably still behind though, right? Because but who knows how the assignments are distributed. Okay. So we got that. We got all the assignments that they haven't finished yet. And we can see that there's 167 of them. And I can always just find out how many they haven't finished by, instead of getting the name and the ID, I could just count this. And now I can see that this, oh, of course. I don't need that anymore. I don't need the order by because I'm not. Okay. So now it says that this student has not finished 167 of the assignments. Okay. Go back to that. So the first thing I'm going to do is select star from assignments. Because this is going to give me back a list of all the assignments that we have. Okay. And I'm going to start with that because I now need to figure out for that student which of these assignments have assignment submissions. Right? I need to join the assignment submissions table where the student ID is equal to 159, which is the one I'm actually looking for. So I'm going to join the assignment submissions table on. Now I'm joining assignments and assignment submissions. What do I need? What condition should I use? Okay, which specifically? So assignment submissions should have an assignment ID, yeah. And that's equal to assignments.id. All right. So we started with 424 rows. And now I've joined a table. And now we have 72,000 rows as a result. Because for every assignment submission, we're going to see the assignment and its submission here over and over and over again. Every student that submitted that assignment, we're getting that result back. So you're going to have a lot of duplication on the assignment information, but you're going to have unique identifiers here. Let's see, 252, 253, etc. Or I guess the IDs here. Okay. So what's the next thing that we want to do? This is starting to take shape. I've got way too many rows here. Maybe I need to find out which of these rows have the student ID of the student we're actually looking for, right? Because this is going to actually be all the assignments by all the students, whether or not they're in the program or not. So we want to do some filtering here. We could say where, I don't know, we'll say where student assignment submissions dot student ID is equal to 159. That was the number that we had. And so now, this is going to actually tell us what here? I've got 257 rows, so we're down from 72,000 to 257, so that actually seems like we're on the right track. What is it that we're actually getting back here, though? There's 424 assignments. So this is actually only the assignments that were completed by that student. We don't have a record of the assignments that were not completed by the student. We only have a record of the assignments that were completed by the student. So we need to come up with a clever way to figure out which assignments the student has not completed yet. An outer join, yeah. And why is it an outer join? Yeah, right. So some of these are not matching, but we want to get a list of all the assignments and then the information about the completion of those assignments just for the ones that are completed, right? So yeah, that's what we need to do here. This join is incorrect. It needs to be let's say a left join instead, right? This is going to give us all the assignments. It's on the left side here. And then we're going to get null values for any assignment that's not completed yet. It doesn't look, oh, left join, let's see. Did I get that right? Let's see here. So, well, what I should be getting with this query is all of the assignments, and then it's going to join this where those match. And for some of them, it's not going to get any matches back, but I should get. Let's just double check what I did here. Yeah. Okay, that's what I wanted to do. So now I'm going to go back and change this a bit. I'm actually going to say I'm going to join on two things. This technically is part of the join, but I'm going to just drop it down so we can kind of see. I think I did that over there. There we go. So here we're going to join where the assignment ID is equal to the assignments.id and the student ID is equal to 159. So here we should get back assignments. And that's what it's missing. And there we go. Okay. Now I have 424 rows here. Okay. Now the reason it didn't work before is because we did the where clause. It filtered out that. I believe it did the filter first. Whereas here we're doing the join right away, and we actually have two conditions. So as long as these conditions match, we'll get data. Otherwise, we're going to end up with a situation like this. As we go down, we notice that there's sort of point in our data here, over on the right side, where now we just have a whole bunch of null values. These are the assignments that have no submission yet. So they're part of our result set, which is important, and we actually only care about those ones. So how could we sort of filter out the assignments or any of these rows that have, that haven't been completed yet? How could we? So submission date could be, yeah, that's one thing. It could be any of these columns here. We could say where the ID is null, where the assignment ID is null. Let's say where the assignment submissions.assignment ID is equal to null. Let's try that. Or is, I think it's just like this, is null. Okay, that's better. That actually gave us just 167 rows. So that tells me that now the only results that we have in here are the assignments that have not been completed yet. We had to use an outer join to do that, right? Because we needed all the assignments, including the ones that were not submitted yet. And then we take that down to a list of, then we use this where filter here to only surface the ones that are null for that. Cool? Somewhere, yeah. Okay. It's not meant that these could be written by you immediately. Again, this is just an effort to show you different capabilities of the language and when we need to consider these things. So I've got maybe chance for one more. I'm actually going to just choose this one here because it uses some interesting thing with dates. Yeah. So I want to find all active students and display their requests per day and average rating. So we're going to find out what the rating of a student is, but also how many assistance requests they make per day. I think that could be useful. So I'll take this over, throw it in here. I'm going to run the query. And what I should get back is something like this. I got 40 rows back. And the reason I got 40 rows back is because the student end date is null. So I'm only looking at active students right now. That's what we're worried about right now. So if the student end date is null, then they're currently in the program. I'm going to only be looking at those students. We've got a list of the students here. And we have the number of requests that they made per day and the average rating that that student has. So we can see from this data that if we order by average, a student that has a low average, I would expect them to have a high assistance request per day. So in that 3 to 4 range here, that makes sense to me. But what I'm noticing is that this person's only asking 1.8 times. So Hetty Hedinger, chances are not asking for the help that they need. And it's possible we have another one. Yeah, maybe this one as well here. Rating below 2, but also assistance request number around 2. And I would expect it to be closer to that 4, maybe 4 per day, just because that's what I'm seeing with other people in that range. So identify an outlier. Let's write this query now. Okay. So first thing I want to do is select star from students. Kind of have to just decide on a table at the beginning, and if you don't, there's not sort of like always start with a specific table. I can't really give you that as a guideline. But I can just say start with a table. So select star from students. And we get back the results. OK. So now what we need to do is we need to somehow get information about these students. One is how many assistance requests they're making in total, right? And 2, what the rating is on average for all those requests. I think if we get that information, we can then find out based on the number of days that they've been in the program. We can do a division, and then we know how many assistance requests they're making per day. Okay. Select star from students. We get this. What table contains the information about the rating and the number of assistance requests? Should I bring up ERD or? Yeah. Okay. You know what? I have a picture of it here. Oops, so it's not assignment submissions, right? We're talking about something different here. So we can ignore assignment submissions and assignments right now. What about from these tables? Which one tells us the number of assistance requests that are made per student and the rating of that? Yeah, it's this one right here, this assistance request table. The rating itself, we can just actually select star from assistance requests where student ID equals some number and then do an aggregate average on it. That would give us the average for the rating. But it's a little bit more complicated when we're actually trying to figure out how many assistance requests they made, because we don't have some column for every student that just tells us the number of assistance requests they've made. We have to compute that value to derive it from the data we have already. So I'm going to join assistance requests on assistance requests .id or .student ID is equal to students, yeah, .id. Okay, so now when I run this query, what should I expect my results to be? How many approximately? 20 results? Okay. Yeah, so how many rows in my results? 70,000. Yeah, because that assistance request table had about that number, I think, right? So what we're going to get here is a result back for every assistance. Oh, sorry, this is 26,000. My mistake. It's the 72,000, I think, on the assignment submissions. But you're right. It's a big number because it's the number that matches sort of the number of assistance requests that were made. There's lots of those. And each one here, this assistance request, we have a unique ID for it. But we'll notice that the same person shows up a whole bunch. Why is the same person here a whole bunch? They made 70 requests, right? So we're getting pretty close, because we can now use this to figure out how many requests were made by each student, right? How do we do that? Group them. Yeah, exactly. Perfect. Amazing. Okay, great. So group them. What do we want to group by here? Students. Yeah. So I have all the assistance requests here, but I need to group them into student buckets, right? So I've got all these buckets, one for each student. I find an assistance request for student A, I put it in there. Student B, I put it there. So now I've made all the. I'm going to group by what student ID? Yeah. So I'll group by the student's ID. So I'm going to make a bucket for every student and put the assistance requests into there. Sorry? Yeah, I'm going to get an error for sure, and then I'll count it, right? So same deal. It does not know what to do with these groups, so I need to fix that. So I go up here and I want to count the students.id. And I get back 190 rows. There are 190 students. But again, if I didn't know that, I would probably go select star from students, see how many there were, and then I'd be able to match those and say, okay, well, good. I've got a count for every student. I think I'm getting pretty close, right? I think that this is now the number of assistance requests per student. What about the average? We got this function here, average. So we can actually average out the students, or let's say assistance request rating, student rating. So here is. So I find it a little bit easier to use the same thing that I group by. If I take the assistance requests ID, we get the same result. But I like that if I'm grouping by student ID, then I would want to count by that as well. The thing is that, remember, we have these buckets, one for every student. And so within that bucket for that student, I have a row, and that row has the student ID, and it has the student name, and it has the assignment ID and the assignment name and all that stuff for each row. So I could technically count any of those things that are in there. For me, the reason I'm doing it is because it matches what I grouped by. Yeah, you're right. You're right. So if it makes it more clear for you, then we could say assistance request.id, and that could work. Yeah, but either is going to work. Because every one of those buckets has a number of rows in it just for that student, and each of those rows has all of these columns on it. So we just need to count one of those columns. Okay. Good. So it looks like here I'm actually getting the average as well. All these numbers are between 1 and 5, I guess, and that was just from averaging the rating here. So once I grouped those things, I could average the rating for each student, and I got that result back. The problem is this count is actually just the total number of requests they've made, not the amount of requests per day. So I'm going to put in the students.name here, because that helps us out a little bit in reading this. And I'm also noticing, I think, that this is all the students. Maybe I only care about the students that are currently active. So where students.end date is not null, or is null. Right, so I want to say only give me the results back where the student end date is null, and then I should take this from 190. Okay, 40, that's probably 2 cohorts. Okay. So, when do you do this? Kind of whenever you feel like it makes some sense, right? It could come at the beginning, it could come after. Point is, I'm just kind of composing this query as I think of things, right? So I've got to deal with this last piece here. How do I average the assistance requests per day? I know how many assistance requests were made in total. Divide by the number of days. Yeah, the number of days they've been in the program, right? So if the junior cohort has been there for 15 days, then I need to take the total number of assistance requests divided by 15. And if they've been there for 32 days, then I need to take the assistance request divided by 32. But my results, there are students from both cohorts, so I need to kind of do this dynamically. I can't just say that this cohort is 15, has only been in for 15 days and just divide this by 15. I need to ask SQL to count the number of days that the student has been in the program. So this is a situation where we might find Postgres, days in date range or something like that. I search for something like this. Oh, look, it's purple. Huh, must have been here before. It's going to kind of give us some ways to do this, right? Select date part, month, age, etc. The documentation here is going to help us with this approach. I've got a Postgres-specific way to do this here. What this is going to do is it's a function Postgres provides to me. I don't expect this to be available in MS SQL or MySQL. I expect this maybe just to be available in Postgres. But I also expect that MySQL has a way to do this. It probably just won't be exactly the same. So sometimes that happens. SQL can be consistent, but maybe we're given some of these functions that are not consistent across all implementations. So keep your eye on that. This one I think specifically is not. So it's a function that we'll call, and what we'll do is we're saying that we're interested in days, not months or years, but we could use this function with days and years and months as well. And this is the range. It's actually kind of cool how this works, but we can give it the date that we want to end on, which in this case is January 1st, 2019. That's the last day of our data. And we know that the student that we're looking at that point, at that iteration, they have a start date. So we can find the difference in this date, and this function will give us back the number of days there. Okay. Now, I didn't include weekends and all that kind of stuff because I didn't want to make this too complicated, right? So, yeah, sorry about that. But roughly gives us the idea of how we're dealing with this stuff. So, oh, and actually, very interestingly enough, I actually did it. This was assistance request ID. So when I wrote it, maybe I changed it after I did it at the beginning. I actually couldn't tell you. I don't remember. Yeah, it's good that you pointed that out. OK. So I'm going to take this here, this function that I'm calling, and I'm going to take that count, and I'm just going to divide it by whatever I get back in this function. I could test this out first and just say, I just want to know how many days the person's been in the program. So I could take this date part thing and make it its own separate line here. And I'm going to say that this is as days in program. So I'm just giving this a name for my column. And so I should actually get 4 columns now. Oh, count. Here. Comma. I just forgot the comma. No, don't be alarmed. OK. So here, I've got this days in program column, and if I sort by it, I see that there are a number of students that have been in the program for 15 days. And then if I keep going, a number of that have been in for 43. So we can see that depending on which student it is, we're getting those different values. So if I take that now, this date part thing, and I now divide it by that 15 or 43 or whatever it is, and I say as AR per day, so this column is now going to give me the assistance requests per day. And there we go. We can see that if I go back and I run this query, that Hetty Hedinger, 15 days in the program, 27 requests made. So when we actually run this now, 15 or 27 divided by 15, 1.8. Does that seem right? Yeah. It's good to verify these things. I mean, I'm not the best at these, so I tend to go back and verify that I actually get what I expected out of it. Okay. So that covers 3 out of these examples here. Definitely invite you to run this. If you actually want to get the database set up locally and you're having trouble with it, like I said, you import the schema file, then the seed file, and then you can make queries on it. If you're having trouble with that, please message me. I'd love to help you with that. And then you can start to run these queries, modify them, build them up. You could go through and just say, well, let me start by finding all the average inactive cohorts and identify blah, blah, blah. Well, then you can come back to this and check to see what your answer was after. And it's possible they're different because there's not always just one specific way to do this. Usually, you know, it might be a difference in the order of the joins and stuff like that, but for the most part, your query should look pretty similar. All right. So I want to talk a little bit about performance before we finish off. And performance is not important to us as much through this program as it is when you actually start building apps for a company that's paying you money, right? So we do worry about it, we learn about it, and for our midterm projects, we don't think so much about it. For our final projects, we don't think so much about it. But I want to talk to you about how we address the problems when they do come up. Okay? So let's divide our world into 4 quadrants. And these quadrants represent sort of different qualities of a SQL query that I might make. Okay? So if I make a query, and that query takes a very long time to get the results back, then I would say that it is a long query, and it fits on this vertical line. Okay? I'd also say that within my application, it's possible some queries are run more often than others, right? So I could say that a query is run many times, and so it would be on, go to the right side of that middle, that horizontal line. So we want to worry about the queries that take a long time and are run often. That's where we want to focus our effort, right? If we're going to run this thing all the time, it should be a short query because otherwise our database gets tied up. If it's a very short query and it's not run very often, well then we don't really need to think about performance so much, right? It's not something we're going to spend our time address and optimize. And then you've got obviously the other areas which are many, you call it many times, but it's a short query. Usually those are pretty okay. Or you don't call it very often, but it's a long query. That kind of depends more on when it's called here. So let's think and focus on queries that are long and get called often. And this is not just true for queries, but when you're doing HTTP requests, you need to optimize the ones that you call often and that take a long time. Okay. So let's see here. I think I have. All right. So I'm going to take this query here. Doesn't really matter what it does yet. I'm going to run it. And we notice that that actually took 933 milliseconds to run that query. Okay? It says it down in the corner of my app there. Your results may vary, but what this is actually giving me is it's looking at all of the students in the database, and for every student, it's giving me back an array of the assignments that they've not completed yet. So obviously these students with null, they're finished everything, yeah. And we're going to see that even these early students, you know, this person here, Elliot, didn't finish everything before they finished the program, right? So maybe that's an issue. This query took a second to run. So when we look at this quadrant here, where do we think this belongs in terms of, was it a short query or a long query? I'd say that's a long, anything over 20 milliseconds is probably a little getting longer, right? Although there is no kind of line in the sand. But a second, 100% over that's too much. So who do you think would benefit from a query like this? Who do you think would use this? Who do you think would use this query? Program coordinator, yeah. So someone who is interested in maybe looking at a high-level view of all the students in the program right now and which ones have not completed their assignments. And how often do you think they're going to do that? Maybe once a week. I think so, like at the beginning of the week, yeah. So let's say that query, where does it fit? Long few, yeah. So I think I'm okay with that. Even though it takes a second, I'm getting good information out of it. Maybe I could do a little bit of filtering first and get that time down a bit. Maybe just filter out students that are done the program. Okay, there's options there, but I'd say I'm not super concerned about that but if it was called every time someone made a request to the website, that's when I start to be concerned, right? Okay. So now let's look at this next request here. And I'm going to run this. And it's a very similar query. The thing is I've added where student ID is equal to 159 here. And now I got back in 8 milliseconds the result I was looking for, which was one student and which assignments haven't finished yet. So how does this, in terms of speed of execution, where does it fit? Short, right? Okay, good. Now, who might find this query to be useful? Every student, yeah, exactly, because every student might, in the morning, come to the site, or multiple times a day, might refresh this thing and do a query to see which assignments they haven't completed yet, right? We like to see the check marks go, and that's actually a good feeling. So how often is this query run? Yeah. So, yeah. Somewhere between the middle and many, probably, right? And again, obviously that depends on the scale and how many users there are and all that. But I would say that that is a short query that's run many times. I'm still not spending a ton of time for performance optimizations. So we can use this to figure out where we should spend our time and effort and try and come up with ways to solve slow queries that get run many, many times that way. And both are useful. It really depends on the context we're in, right? So we need to be thinking about how it's being used. So that's kind of what I want to talk about with performance. My final thoughts. Learning this language in a day is overwhelming. It's way too much. Don't worry about the speed of your queries today or tomorrow or midterms. None of us are concerned about that. Just get them working. And if you're curious and it is taking a long time and you want to have someone sit down, do an assistance request and ask for a review or something, maybe there's a way we can speed it up. Maybe there isn't and we need to use it in a different context. Maybe we need to cache things. Who knows? There's lots of options to solve this problem. But we're not going to worry about it today because we're spending enough time trying to learn the language as it is. And then also, once we've learned the language pretty well, then discussions about performance make more sense. But today, discussions about performance, I'm just trying to be general and giving you some overview. But when we actually talk about specifics about indexing and all that kind of stuff, that stuff doesn't make a lot of sense until we actually understand a bit more about databases. So let's get some practice with databases, and then we can worry about performance later. And then this one, here was a big message from me. When you're searching for queries on Stack Overflow, don't just copy and paste the thing, and if it gives you the right results, be happy with it. Don't do that. Find the query. Try it out. Does it give you the results you want? Yes, good. Now write it yourself. It's going to be a way better approach. Because then you can look at what they've done, and you can go back and forth and kind of build it up and see, step by step, how do you get to that same result? Kind of like what I did today. You could just copy and paste those queries into your application, but then we don't learn how you build them, and that's really what we're trying to get out of this. And I can tell you that I have seen Stack Overflow answers that are completely wrong, even though people say they work. So just be careful of that, right? We're not 100%, it's not 100%. There's a bonus here, talks about aggregate functions. For example, you noticed here, how do I get back an array in an SQL database? It's not standard SQL. Not every database supports this, but Postgres does. And I'm using something called an array aggregate for this. I'm doing an array aggregate. Does what? What does an aggregate function do for us? Yes, a lot of rows down to one value. So here, what I'm doing is I'm getting a lot of rows back. It's all the assignment IDs for this student here. But then I'm using this array aggregate function to actually take all those results and put it into an array structure. Now, this is useful, but it's not built into SQL. So if I wanted to switch to another database, this query might not work. But if I just use that at Postgres, then I get to do it, and it's actually a pretty good way to get that type of data into the UI. Because alternatively, what you're doing is you're going to get back a list of all the assignments that they've done as an array of rows, and then maybe not have the name and ID associated with it as easily. So I think this is a nice way to kind of get with that. And lots of aggregate functions here. Look at them all. So there's some JSON stuff in here. We can see count is there. Actually, that's a good question. Let's go back to here. If we do count star, seems to work as well. So remember we talked about, should I use student ID or assignment assistance request ID or what up here? Star also works in that case of the grouping. All right, thanks everyone. Hope Calgary's good. And send me a message if you need anything. Appreciate it. And I will be here for another hour, I guess.